Woi. Hey there, guys, and welcome to the Sarcomeres in Parallel podcast once again, episode 4 and episode 2 in the series of podcast episodes we are doing into the hierarchy of scientific evidence. As we touched on last time, scientific evidence is arranged in a hierarchy with greater quality and less prone to bias research at the top, and then the less quality, more numerous, more prone to bias research at the bottom. The type of research we're going to be going over today is something called mechanistic data. We're going to go over what it is, the pros of it, the cons of it, what it's used for, what it can be used for, what it can't be used for, and talk about some of the limitations to do with human research and scientific research as a whole, especially in the health, wellness, nutrition, sports and exercise science kind of field. So first off, what is mechanistic data? So mechanistic data, or mechanistic research, as the name would imply, is designed and formulated to isolate mechanisms and work out how things work by looking at mechanisms in isolation, so how two things within a system may react. That is why it gets its name. It's attempting to further our scientific understanding of specific things that may give us greater insight into how a bigger mechanism or the wider system would work. I'm going to tick these off on my little list as I go along. So, as I said, it's used for looking at mechanisms in isolation. That's what it's really, really useful for. It's also useful for conducting research that would be deemed ethically inappropriate to be done on humans. Now, you can argue the ethics of that statement, till the cows come home, but the cold fact or the cold truth of this issue is just that science is concerned with getting to the heart of objective reality, and as a result, some practices you can definitely argue have been unethical. If you read some publications, they're not pleasant reading, certain parts of them, but fundamentally it has helped further our understanding of certain mechanisms, which have led to some of the research we have been able to conduct today, and have furthered our scientific understanding of many things that we may not have had insight into without them. So you can argue ethics till the cows come home, but that is another useful aspect of mechanistic data purely from an objective truth-gaining standpoint. Talking about when human data is not feasible, this highlights a really, really important teaching point, and that is when you're doing scientific study, when you are doing some form of research, there's three really big factors that you need to take into account to make your study, to make your research as strong as possible. Pardon me. The tightness of the control regarding the test variables and the participants, the duration of the study, the longer typically the better, and the participant number. The greater participant number you have, the more widely applicable the research findings are, and the greater statistical power a research publication has. With human data, with human trials, you will really only be able to satisfy 2 out of 3 at any given venture. Typically, at any research paper, we'll only be able to satisfy 2 out of 3 of these methodological concerns. And here's why. If you have a really tightly controlled study and you needed to go on for a long duration, you will not get many people that are able to do that or want to do that. If you want to get people to spend 2 to 3 months in a lab, basically some sort of inpatient study where we're looking at metabolic rates and the effects of different diets, and we want to know exactly what goes into those dietary compositions, so we want to make sure there's no deviation, because that would impact the validity and reliability of our results, you're not going to get many people that A, want to do that, and B, can. We're all working people. We all need to go out and gain our livelihoods somehow and make sure we can provide, whether we have families, for ourselves, people got mortgages to pay, etc., etc. So if you have a very, very tightly controlled study, it's very, very difficult, especially over a long duration, to have a high participant number, because there's simply just not many people that can do that. And think, you've got to give people incentives to want to do this study, whether that's in the form of payment or some form of compensation. Otherwise, these scientists have to find funding for these studies and a way to compensate their participants. So if you have a really tightly controlled study over a long duration, you're not going to have a high participant number, and that makes the study a lot less powerful and makes the results a lot less widely applicable. Now, if you have a long duration but a high participant number, you sacrifice controllability. And this is one of the key things that we want when we're doing a scientific study. We want control over the variables, because if we don't have control over the variables, how the hell do we know how they're interacting? This is one of the key limitations of what we would call a free living study, where participants, they're doing a weight loss study and they're allowed to go home and do their regular routines, and they just have to do like regular check-ins. These can be useful, but in that time, you don't know what exactly they're doing. You don't know if they're following the diet, especially if this is over years and the check-in is monthly. You don't know what they're doing the other 31 days of that month and every month, or whether it's bi-monthly, whether it's twice annually. There's methodological concerns with free living studies, self-reporting errors if you're looking at a nutrition study. People very much so like to underreport what they actually eat and overreport the exercise that they do. There's many, many concerns with a free living study. But you have to understand, you have to make this sacrifice if you want high participant number and you want a long duration kind of study. That's typically what happens. You can't have the control that you would like to. Finally, if you have a high participant number and tight control, you're only going to get that in humans over a short duration. Again, people can't take stupid amounts of time away from work, away from their families. People just can't do it. It's not feasible. But without it, it's hard to make long-term recommendations with short-term data. With short duration studies, it's hard to make long-term recommendations. You can only hypothesize, and that's good for informing future research, but for making definitive cause and effect statements beyond the study time frame can be difficult and potentially negligent to do so. So that's the key limitation areas with regards to human trials, is that typically you can only get 2 out of 3 of these variables satisfied fully. If you want 3 out of 3, you need an animal model, unfortunately, or it's some form of cell culture analysis where you can have stupidly high numbers of cells, very tight control, and you can analyze them for as long as you basically want to, till the cells die or whatever. That's where mechanistic data can come in handy. However, there are issues with mechanistic data, quite big issues. Direct extrapolation is a big issue. You can't necessarily just say that something is true because it was observed in an animal. If something was observed in a rodent, in a frog, in a cell, in a cell culture, in a petri dish, that's not a human. In terms of human data, human trials, making definitive statements about what's good for humans, for example, artificial sweeteners is a big one. Just because something is lethal to a cell when it is pumped full of thousands of times above the dose that we would have in humans for example, this, doesn't mean that that substance is going to kill a human if it results in the death of a cell. Similarly, if we observe an effect or mechanism in some form of animal, doesn't necessarily mean it's going to work the exact same way in a human model. This is very, very important to consider, because people will try to cite animal research over human research in order to support some of their points, particularly if they have something to sell you. And you need to be very, very wary of this. Anybody who chooses to cite an animal model or animal data or cell data over high quality human data purely because it fits their narrative should be shown the way, i.e. kicked to the curb and not listened to. So bear that in mind. There's another big issue with mechanistic data, and that is differences in the wider system. You cannot always make definitive statements on them from a single mechanism. Big example with regards to this, especially from a nutrition field, is that people like to say carbs cause this increase in insulin, and insulin inhibits the process of lipolysis, which is fat oxidation. And while that in the short term is true, and if you take that as a mechanism, you think, oh my god, then I can't eat carbs. But actually you can, because it neglects the wider concept of fat balance. So if we're looking to lose body fat, for example, fat balance is referred to as the relationship between fat storage and fat oxidation, i.e. fat burning. Now, if you are on a high carb, low fat diet, for example, yes, you will burn less fat, but you are also storing less fat because you are not eating as much fat. If you are on a high fat, low carb diet, for example, a ketogenic diet, then yes, you will be burning more fat because you're not intaking the carbs that the body would normally use for energy in the form of glucose. However, because your intake of fat is so much higher than a person on a low carb diet, you will also be storing more fat. That is known as fat balance, and it is a concept within the wider structure of energy balance. So if you was to just take carbs, insulin, obesity, that's completely neglecting the wider concept, and you're relying on a single mechanism to do so, when in the context of the wider system, that's not the truth. So that is why you have to be very careful with mechanistic data. I think the final one then is, based on what we said here now, is that definitive statements of cause and effect cannot be made on mechanistic data. For definitive statements of cause and effect, you need to start looking towards the higher quality evidence in humans, and those come in the form of randomized control trials, meta-analyses of randomized control trials, and systematic reviews of randomized control trials in humans. We're going to be getting onto those as we go through these episodes, and that's that. Just a little bit of a recap. So mechanisms, guys, mechanistic data, we are looking at a single mechanism, or doing some form of study that we can't really do in humans for whatever reason. Again, debate the ethics of that however you want. You can debate that till the cows come home. There's many issues with trying to get the perfect study framework in humans, and that's why sometimes we go to animals or go to other forms of mechanistic data, because we can satisfy the tight control, the long duration, and the high participant number. However, you have to be careful extrapolating data from animals or from cells directly to humans for the reasons we touched on. Same thing with difference in environments and how the mechanism fits in to the wider system at play. And finally, the definitive statements on cause and effect cannot be made. And there you go. You're better informed on mechanistic data than you were 22 minutes ago. Thank you very much for watching and listening, guys. I hope you have an amazing day. Now go train. Out.